Hi, this is Mark Phillips. I'm from the University of North Texas over in the United States, and I wanted to take a little bit of time to walk through some of the work we've been doing with our around metadata quality in our digital library system here at UNT. So first of all, the UNT Libraries, we operate three major digital library interfaces. The UNT Digital Library, which I have on the screen here. There's the Portal to Texas History, which is a repository that we operate with around 380 partners from around the state of Texas. They host all of their content through the platform, and metadata is created through that platform. And then the Gateway to Oklahoma History, which we work with the Oklahoma Historical Society to operate. All of these digital library interfaces operate on the same metadata editing backend, and it's an application that we've been working on developing here for editing metadata and understanding how metadata works in our system. Right now we manage just over 2.1 million metadata records in that system. This is the main view as a user comes in when they have access to all the systems. It can also be limited to just a single collection or a single partner institution. You're presented with a search interface where you can go through and search for a specific record. You can do a fielded search. There are a number of different ways to sort the data that comes back, various dates, creation date, date it was added to the system, date last modified. Whenever a record is clicked, you are given a summary page for the record, which displays information about the history of the record. You get a little edit timeline, which shows kind of what's happening over the history of the metadata record. You're able to see a quick view, whether or not it's visible, unlocked, whether or not the record is complete based on a pretty simple completeness metric that we use, and then also if all of the dates are valid according to the extended date time format. You can also take a look at the history of the edit record, of the metadata record, to see when things have been changed. And you can even roll back and look at previous versions of the metadata record as needed. So, but I think the thing I wanted to start with, so we have three interfaces that we've been working on for working with metadata quality. And it's really just allowing us to see different views of metadata for the system. The first is just a simple listing of all of the values in all of the fields, and it's based off of the Solr facets, and it's just really just iterating through all of the values that occur within a field. So if I'm looking at our subject element and just saying, give me all of the different kinds of subjects that you could have, you hit a search, and immediately it fires off a query into the Solr index and brings back just kind of a paged list of all of the facet values along with the counts of the instances. And then once those display, there we go, you're able to quickly find something that you're interested in, and when you click on the element, it actually takes you into the interface with just that single item, or with all of the records that match that query that you can edit. You can also, if you want to jump into later into the records, you could say, give me all of the search, the subjects that start with P, and so that'll immediately start paging you at P. So that's facet. There's an interface we call count, which is giving you the number of instances of a field, and so in this situation we'll look at the description field. In our metadata, we like to have two descriptions, a physical description and a content description. Physical description kind of giving you the pageant numbers of pages, the physical description of the item, and then the content description is really what that item is about. So we generally like to have two descriptions, and so you'll see that the majority of our records, 1.9 million of them, do have those two records, or do two descriptions. there are 151,000 that only have one description, and there are 44,000 that have zero descriptions. You can click on the value of 0 and immediately pull up the records that do not have a description. Many of these are hidden or need to be modified in some way. You can also go through and choose a specific qualifier. You could say, give me the count of records with the description that have content descriptions or physical descriptions. And then we also index with kind of the opposite of that. Give me the number of records that have that have zero descriptions. And so you'll see that or that don't define what kind of description it is. So there may be two descriptions, but at least one of those is not defined. So if we click on that one item, it'll pull up the search result. We can quickly jump in and go through and edit that search result. We can go down to the description field, and we'll see that this one has no qualifier selected. We'll go select the physical description because that's what the description is. We'll hit publish, and then that record is then published back into the infrastructure, and there's a new version of that record created. So the other interface that I wanted to look at was the cluster interface. And so this is actually just taking the concepts out of the clustering mechanism in OpenRefine and implementing those in Python in our Django web app that runs this edit dashboard. And so once again, you can select, in this situation, we're going to select contributor. We're going to say, give us any of the kinds of contributors. These are generally kind of the qualifiers could be the role that they have within the object. And then you can apply different algorithms to this. The one that we generally suggest is just the fingerprint algorithm that is discussed with the OpenRefine clustering. What you get back are clusters based on that algorithm of the values. And so you'll start to see that many of these values are very, very similar, and that the only difference they have is whether or not like names are inverted or the orderings. There are a number of different ways you can sort these. By default, they're sorted by key, A to Z. You can split that up. You can go by the number of members, high to low. And so this would be the number of different different value types within a cluster. And so our great poster child for a good example is Shostakovich, which we have 14 different ways of defining in our data set. So obviously we need to go through and decide which version of Shostakovich we want to use, and then edit the records accordingly. You can also choose the elements that have or the clusters that have the most records, or then you could start looking at the average length or the average variation. So just different ways to look at the same sort of data. There are some variations on that fingerprint algorithm that we use that are really simple. No space. So what character is used whenever we replace punctuation? Our default implementation replaces any punctuation with no space, and then with a space, excuse me. And then the NS is no space. The ND removes dates. And so anything that looks like a date, and this is particularly useful for values like names. In libraries, we have lots of dates in our names, and so if you go through and sort again by the members high to low, you'll see that it'll start to include some variations that don't have names or don't have dates. So like 4A here doesn't have the date present. There is a variation that I think is really nice. So we try to do a lot of work with dates, and so you can actually go through and use a pattern mask, and that just converts all letters to a single character or a single representation, and all numbers to a 0, I believe. And then because these end up returning very, very large number of values, we actually implement a sampling method. So either you want to randomly sample or the first or last 100 alphabetically or frequency. And so when you do this, you hit your submit, and what it'll come back with is your all of the values, the way that they're clustered, the binning that they use is based on a pattern mask. And so this is still sorted by the high to low number of members. You can see that there's 63,000 different versions that are just year, hyphen, month, day. And so we limit that to 100. And then we have variations based on time. We can go through, and when you look at it based on key, you can see very quickly the different ways that dates are represented within the data set. And so you can see when things like this first value here is going to be something that needs to be changed, because you can't have 3-digit dates in extended date time format, and you can quickly jump into the records that need to be edited with just that value. You can click into the record itself, and then what will show up is the interface tries to highlight where the extended date time format is not correct. You can jump into that date and then adjust as needed and save your work. It will try to revalidate, and then you can save that record and go on. So thanks for letting me do a little kind of distance presentation on the edit interface that we have for our digital collections here at UNT. I try to write a little bit about this work on my personal blog, and then we've also tried to do a little bit of publishing about some of the interfaces that we're building out. And I'd be happy to field any questions over Twitter. My handle is VPHILL, VP Hill, and would love to talk to you about the kind of work we're doing. So thank you very much.